Hello everyone. In this video, I'm going to do a simulation for a RFID tag reader with an Arduino Mega board, not with an Arduino Uno board. This is with the Arduino Mega 1280 board. So an RFID tag, that is like a radio frequency identification tag reader, that is a device to use read RFID tags, which are small electronic devices that contains data. Inside that, it will contain a data. That data we are going to check with our required data. If it is a valid tag, then it will give a message as it is a valid tag. If it is a not valid tag, then it will give a message as it's an invalid tag. Using this RFID tag, we can use to create various applications. And we are going to use a Arduino Mega board. Arduino Mega board is a microcontroller board with many pins and memory that other Arduino boards do not have. Now this Arduino Mega is updated version of the Arduino mode, and now we are going to show a code. I am going to show a code. This is the code for RFID tag reader. In this I have declared three variables, global variables. This count is to identify how many characters I am entering to the RFID tag. We will get the RFID tag from the user. So each characters will get counted in this character C. Character C, if I am giving a string as a hello consists of 5 characters. So line by line the characters will get read in character C, HELLO, that like it will come one by one, and the count will get incremented to 5. And the this string ID is used to store the full string into this ID, global variable ID equal to HELLO. This full string will get stored here, and each by characters will get read here, and the count will declares the count globally, and finally the count will be the number of characters inside the program what the user entered. And I am using a function called void setup. This void setup is used to initialize the serial communication between the Arduino board. So I am using serial begin keyword. This serial begin keyword begins the serial communication to the Arduino board. So we are giving bracket 9600. This means the baud rate of the board. The baud rate of the board we can give it as 9600, so that we can initialize a serial communication between them. So pin mode, in this pin mode I am setting the 21st pin as an output pin. 21 pin will connected to an LED and a resistor to LED to the grounded, so that if it is a valid tag, this LED will get blink. If it is a non-valid tag, this LED will get off, so that we can identify we are entering a valid tag or not. So I am using a function called serial println in the next line. This serial println will print this message: please scan your RFID tag into the visual terminal. So we are using two visual terminals here. One is to get the output that is a valid tag or not, and another is to paste the RFID tag the user is entering. So why we are using these two visual terminals means one visual terminal we can able to copy and paste, so that we can get the output in another visual terminal. And this we are setting this all functions inside this only. So we are going to begin the serial communication using this keyword serial.begin with the baud rate of 9600, and then we are making the 21 pin as output pin with the connected to an LED, and we are prompting a message like please scan your RFID tag. Then we are coming to the void loop function. This void loop function is used to continuously checks for the incoming data from the RFID tagger. So the user is entering the RFID reader message, RFID reader tag, so that this loop will check character by character, and it will store into the string ID, and then it will check for the it is a valid tag or not. All these functions will get into this void loop function. So in this void loop function, serial.available, this function is used to returns the number of bytes available to read. That is how many characters we have written, so that number of bytes will get read here. So if it is greater than 0, the code enters the while loop and the code got executes. So C equal to serial read. This function is used to read a character from the serial buffer. So this will read the data. It is like a scan of serial dot read. Then it will read the character one by one, and after reading a character, the count will get incremented. The count will get incremented means how many characters will is entering. The count will be that much of number, and ID plus equal to C. This appends the character equal to into the ID. So this character will get stored into this ID. Every character entering into the serial read will get stored in this ID. So this ID will so using this ID variable only, we are going to check with the actual RFID tag reader. So if the count equal to 12, so we are giving this AB 1 2 3 4 5 6 7 8 9A. This consists of 12 characters. So this 12 characters, if a count will get us 12. If one by one character is getting into this serial read, and the count will be 12, and ID equal to ABCD 1 2 3 4 5 6 7 8 9A. So these many options will done in this set of code. So after that I am checking that count equal to 12. That count ABCD, this string is equal to or not. If it is equal to, then it will go into this serial print function. Serial print function is prints the full RFID tagger to the serial monitor for verification. For verification purposes, I am using the serial print ID, and then I am checking the ID. The user have entered, and that is stored in this ID variable. I am checking with that ID variable with this actual RFID reader what we have mentioned. So if it is equal to this ID equal to this RFID tag, then it will print a valid tag. This serial printer is used to print the prompt message in the visual terminal, and then I am using like if it is a valid tag, it will the LED will get blink, and it will give the message as valid tag, else the LED will get low. If it is the valid tag, I am giving this digital write, the 21st pin should go to high. High means the 21st pin is connected to a LED. So if it is go to high means the resistor will make the LED to blink. Else if it is not a valid tag, the LED will be in off state, and it will print the message as invalid tag. And I am resetting the count variable, global variable count equal to 0, and I am giving a delay. Delay is used to give the valid tag. After some delay, if it is a valid tag, then it will print the message as valid tag. Now I am going to compile this program. I am going to compile this program. After compiling, I want to extract the hexadecimal file, and I am going to paste it in the Arduino board. If I get pasted into the Arduino board, then this entire code of this code will get dumped into the Arduino board. In some other microcontrollers, we want to copy the whole entire code and we want to paste it over the board, but in Arduino we can only extract using the extraction of a hexadecimal file. We can easily dump the code into the Arduino board. If you drag little bit more here, you can find a .x file here. This is the hexadecimal file. So copy this from here to here and copy, and now I am going to go to Proteus. In Proteus, this is the Arduino Mega 1280 board. This board is we are using for the RFID tag now. So I am using two visual terminals, 1 and 2, and I am using a resistor connected to a LED to grounded. This will connected to the 21st pin as mentioned in the code. 21st pin. This 21st pin I am connecting to a LED so that I am able to identify that the user is entering a valid tag. If it is getting blink, then I can able to identify the user have entered a valid tag. And I have entered and I have connected one visual terminal is transmitted to receiver of the Arduino board, and another visual terminal is receiver to transmitter of the Arduino Mega board. So this Arduino Mega board has having many pins compared to Arduino Uno. This is a powerful microcontroller. So now I am going to dump the code into this Arduino board. So here a program file will be there. You want to paste it, the hexadecimal file which we have extracted there here, and we want to give OK. So it's a simple structure, same like Arduino normal board RFID tag reader. So I am going to run this simulation. Always we want to check that we are compiling this board into an Arduino Mega board. Yeah, I am getting compiled this an Arduino Mega. After completing, once again compile this code. Yeah, after compiling, once again copy the hexadecimal file. And then again paste it over here. Then again run the program. So we have here came the two visual terminals. Here one visual terminal, here one visual terminal connected to the Arduino board. So I am going to paste the RFID tag reader which the user have entered. I am going to check with the RFID tag which we have written. We have written to the code ABCD 1 2 3 4 5 6 7 8 9 A. This I am going to paste it over the visual terminal and check whether the user have entered the correct RFID tag or not. So I am going to paste it over this terminal. If it is a valid tag, then here the message will come valid tag. Yeah, AB 1 2 3 4 5 6 7 8 9 valid tag. The message came as valid tag. So this is the program I have written for the Arduino Mega board. So I am going to check with another RFID tag reader. That is like another RFID tag reader, so that we can identify it is showing correctly. It is showing correctly the RFID tag. So I am going to paste it AD count. So this count I am going to copy and paste it over the RFID tag and check it whether this is showing a valid tag or not. I am pasting it here. So it should come valid tag and the LED should be in off position. Invalid tag. Yeah, the LED is in off position. So it is initializing that it is an invalid tag. This is the code for the Arduino Mega board. Using Arduino Mega, it is a simple structure of Arduino Mega to check an RFID tag reader. You can use it in Arduino Uno board also. You can use it in Arduino Mega board also.